The central limit theorem takes pride of place as the crown jewel of the classical theory of probability. We have seen its long and glorious history as it evolved from its early beginnings in 1733 to the very rich, all-encompassing domain that it seems to encompass today. Let me conclude our presentation of the central limit theorem with an application in a setting of some subtlety, the issue of fraud. And what I will talk about is fraud in academic circles, or at least the accusation of it, what statistics has to say about this, and where the central limit theorem comes to play. So this is the curious case of Sir Cyril Burt, psychologist. So let me start by telling you what the background is. Cyril Burt was one of the preeminent psychologists of the 20th century. He was a fellow of Jesus College at Oxford University, a fellow of the Royal Academy. He was the first psychologist to be knighted in 1946. And he retired from his professorship at the University College London in 1950 after a long and extraordinarily successful career. He continued to be very prolific, publishing widely after his retirement, and from 1950 onwards until his death in 1971, he published a large number of papers. He was well known for his studies of identical twins, very influential studies. But today, I shall look at a study of his on the heritability of intelligence. He published a paper on IQs and how intelligence is passed on from parent to child in 1961. Turned out to be a very influential paper. This was a setting when he died in 1971, 10 years after the publication of the paper. And everything was rosy for a few years until in 1974, Leon Kamen at Princeton University published a book called The Science and Politics of IQ, in which he cast doubts about the usability of Burt's data, with a strong imputation that perhaps there was academic fraud in the presenting of the data. This was, of course, in the words of Tennyson in The Lady of Shalott, a rift in the lute, which growing still makes the music mute. Kamen's accusation against a personage of such renown caused immediate and strident protest. Colleagues, students of Burt leapt to his defense, and accusations and counter-accusations were traded freely. The story has legs, and to date a very large number of points and counterpoints have been raised in the scientific press and in the popular press on this issue. What we shall do today is take a look at what statistics can say about this. And as we shall find that, yes, indeed, a principled statistical approach to the problem can shed some light on the issue. But, as always, in the application of formal models, mathematical models, to a physical reality, we shall find that there are limitations to what the models can say. And there are some things that statistics and probability cannot say. So this is the background. So let us leap directly into the issue. And this is the case of IQ data that was presented by Burt in his 1961 paper. So this table is taken directly from Burt's paper, and the listener should feel free to verify that the numbers are presented are indeed accurate. it is unfortunately all too easy to make mistakes in this kind of data entry and in the analysis of data like this. Right? So some caution is always advisable. This was one of two tables that appears in Burt's paper of 61. This was his presentation of IQ data, intelligence quotient data, for adults. Now, a student today has assuredly heard of IQ tests and possibly has taken them when they were in elementary school, perhaps, or perhaps out of curiosity over the internet. The test itself, in its original form, was developed in 1912 by the German psychologist William Stern. Today, if one takes a test out of curiosity over the internet, one could do a test in, say, 20 or 30 minutes, though such tests are considered unreliable, they are unproctored. A proctored test might run anywhere from an hour and a half to 2 hours. Right? So these tests are not simple and easy to administer. They actually take some time to do carefully. Keep that in mind. This has a bearing upon how the story unfolds. So here are Burt's data. What did he present? Well, what Burt did in his paper was break up adults into 6 professional categories, what he called Category 1, higher professional, all the way down to Category 6, unskilled. These IQ tests then were administered to a population characterized by these occupational characteristics, and then IQ scores were recorded and tabulated. So you notice that you now have a spread of IQ scores, and if one believes that higher professional attainment is somehow correlated with intelligence, then perhaps the table seems to reflect that kind of understanding. In any case, these are the numbers that were reported. Pause and take a look at them. Right? So the IQ scores, as is typical, range from somewhere around 50 to 60, all the way up to past 130. Scores in the 50s and 60s are considered deficient. Scores above 140 are considered a genius level. Right? So you can see now a spread of scores for intelligence. Pause the lecture and look at the table from a higher vantage point. Right? Let's not do an analysis yet, but look at the numbers holistically. Does anything leap out at you? Does anything look a little strange, perhaps? Something that needs, perhaps, explanation? Right? Pause and take a look and come back when you're ready. Oh, you're back. Now, perhaps one thing that might have struck you is that the number of people that were tested was exactly 1,000. Were exactly 1,000 people tested? If you've done any kind of data collection, you realize that it's sometimes difficult to get such perfect whole numbers. Right? We might anticipate we try testing and we end up with 998 or perhaps 1,002, but perhaps that's okay. Well, I could imagine that a succession of tests were done until exactly 1,000 people were tested, and then it was stopped, perhaps. Here's another number which looked a little surprising. In the last column, in the aggregate and the total, the mean IQ, the arithmetic mean of the numbers in the table, are tabulated. And you find that the total is exactly 100. Now, this seems certainly a little more strange. One would perhaps not anticipate that if one collects data at random, 1,000 pieces of data, that the averages would add up so beautifully to a whole number, exactly 100. Perhaps that one actually does need some explication. Now, here's one more feature to keep an eye on, and I'll ask you to remember this. In the higher professional classes, Class 1, it looks like there were exactly 3 people who were tested. Okay, was it 3 exactly? The numbers, of course, feels a little low to be forming statistical conclusions, but perhaps that is in fact reasonable. But in any case, according to the table, 3 individuals are tested in the higher professional category. Now, this is the first of 2 tables that Burt provides in this paper. And except for the formatting, I've tried to keep the structure of the table, keep the integrity of the structure intact. Now, Burt was interested in the heritability of intelligence. Is intelligence actually passed on from parent to child? So, to accompany this table of IQs for adults, he listed now a table of IQs for their children. And here it is. And again, it's a table very much like the previous one. The children were tagged with the professional class of the parent. So again, the children appear in the professional classes 1 through 6, from higher professional all the way down to unskilled, and those classifications refer to their fathers. Again, you notice a spread of values, and there seems to be a high correlation again between children of more accomplished parents and potentially higher IQs, and with children of perhaps less accomplished parents seeming to have more variability and perhaps smaller IQs. Again, if one believes that intelligence is a heritable characteristic and that higher professional classes, higher attainment in professional life suggest a higher aptitude, a higher intelligence, then such data seem to be in support of these hypotheses. Again, the 2 factors that we looked at earlier strike us. We've got exactly 1,000 children represented in this table. The mean IQ across these 1,000 is again 100. And in the higher professional category, we have 3 children represented. So there are questions to be answered about the data and its presentation. To resolve them, we are going to have to turn to Burt's paper.